Hello everybody. My name is Bilgeçağ Aydoğdu. I'm doing PhD at Utrecht University, and today I'm going to talk to you about our research with Özge and Albert Ali, who are my supervisors, on mobile phone data for anticipating displacements, practices, opportunities, and challenges. This came as a result of our collaboration with Turkcell technology and as a part of Hummingbird project. That's a Horizon 2020 project. So I would like to also thank to them for this. So to begin with, I would like to talk to you about the context. So forced migration due to disasters and conflicts are on rise. 2022, we see the most amount of displaced people, basically all time recorded until that day. So preparing and responding to these crisis events is becoming more and more important for humanitarian actors as well as policymakers. So in such context, often what we're missing is timely and accurate data. There are ways of collecting data, but in such situations, often it's becoming more and more difficult to access much needed indicators of displacement. Who is displaced, where to displace, etc. So mobile phone data has high potential in addressing these needs and responding some of the problems that we faced in this context. In our research, we first focus on developing a pipeline and offering a pipeline to process mobile phone data sources for anticipating displacement, basically for analyzing the mobile phone data, output of mobile phone data processing for predicting and better responding displacement scenarios. In the second phase, we look at the opportunities and challenges of using mobile phone data in such predictory analysis. So there are different types of displacements. Often we categorize displacements as either being caused by disasters, natural disasters, or conflicts. But such binary way of looking at displacements is also not so realistic, because some of these reasons sometimes coincide, and it's hard to say that they are so binary. But we still want to use this framework, because in the context of using mobile phone data, it kind of helps us to be more systematic, and being more systematic helps with quantitative data-oriented approaches. So disasters can include earthquakes, wildfires, floods, etc., and conflicts are armed conflicts or violence events, etc. So then we look at what type of events that displacements include, what time-related effects they have, and their locality and concentration of effects, intensity and size of displacements, the return prospects, population effects, seasonality, and prevention and preparedness for both disasters and conflicts. In each all these dimensions, we see a difference between conflicts and disasters, and we use these differences to better understand how to use mobile phone data when we try to develop indicators of displacements in the context of conflicts or disasters. I'm not going to go into much detail of these things, but it's great to keep in mind that there are some differences between these two, and they have consequences for mobile phone data pipeline. So the pipeline we kind of showcase here is best manifested in this figure. So it's the pipeline starts with mobile phone data acquisition, continues with features and indicator calculation, and then at the end we have the analysis part. So first we have the data preparation part, where we kind of access the mobile phone data and we anonymize it, and aggregated for ethical data processing. But before we start, I want to give you a brief overview of what mobile phone data looks like. Here at the upper side, we see a CDR example, which is a call detail record. And below that, we have XDR example, which is extended data records. Both of them are collected by telecommunication companies, and they give different insights on their users. The CDR data is showing timestamp communication pattern between two phone users. And it's showing you how long the duration of the call was. But beware that the content of talks are not known by the company, so it doesn't include the actual speech of people. It's just location data and communication data. Whereas extended data record shows the internet usage patterns per user, and it is more frequent data in terms of how many data points there is per user. It's also timestamp, and it also shows the location, but it doesn't really tell us anything about the communication patterns. Well, it's great to keep this in mind to understand what kind of data we deal with. But this is the raw data. So this data is extremely private and sensitive, and it requires ethical data processing. So what does it involve is first anonymization, aggregation, and group selection. Not going into too much of detail, anonymization means that the personal identifiers are removed from the data. So the individuals are not being able to track and kind of identified. It is an extremely difficult thing to do because mobile phone data gives a lot of information on users. So to do so, there are various methods that we follow, such as reducing spatial information or the temporal information per user. But what is more important and common to do is to aggregate the data. When we aggregate it, there is no possible way to identify individuals because we do not have individual level data. A further action is often also done by removing data points that are lower than certain threshold. In this way, it's difficult to even say even if the data is aggregated with very low amount of data points, there is still a possibility of guessing who this individual might be in a specific location at a specific time. But yeah, it's extra level of safeguard of protection. Lastly, group selection refers to basically selecting certain demographic groups, because mobile phone data is actually extremely useful for developing demographic proxies, such as somebody's wealth situation or somebody's ethnicity. Looking at these demographic or somebody's gender. So including this demographic information is both useful, but also making the data even more sensitive. So there is an important balance here between privacy and utility. But nevertheless, we use these methods to calculate important indicators of displacement. And that brings me to the second part of this pipeline, where we calculate features and indicators with mobile phone data. This involves also triangulating the data with other data sources. So what I mean by features and indicators, it has two sides. First, I'm talking about easy indicators that are basically one number showing one aspect of the data, such as amount of calls from a region, let's say, or how many contacts somebody has, and what is the average number of contacts in a given locality. This kind of easy to calculate indicators. But there are also indicators of displacement, which includes talks and flows. Here, we also need to go back to the definitions of how we define certain types of displacements, because a displacement can be cross-border or internal. Internally displaced people are called IDPs, whereas cross-border displaced people can be called refugees or asylum seekers. So to develop these indicators, we have to approach it a little bit based on the context. I will give examples of this, but as I described, there are two main things to look at when we look at features and indicators. Let's start with what I mean by low-level features. Here you see an example of individual level indicators calculated by a tool called Bandicoot that was developed by researchers at MIT, and is showing different aspects of somebody's call detail record, such as number of interactions per day that somebody has, or number of interactions, the percentage of interactions that somebody have by night, the number of outgoing calls, incoming calls, average call duration, etc. So these are not telling us much about the displacements themselves, but they can be predictors, or they can be used in more complex models to increase the accuracy of predictions. They can be also they can be also informative by themselves. An example of this is a recent study that we have been doing that is under preparation, where we look at the role of social connections in the crisis-induced migration, in which we look at the earthquake that happened in Syria and Turkey last year in 2023, which caused millions of Syrians and Turks to be displaced. So here we look at a specific formula that we calculated in our data called radius of gyration, which gives a metric on how mobile the population is. And then we look at this, the distribution of this metric in different times and spaces. So despite this being an low-level feature, it still gives us a sense of displacement. As you can see in the left figure, the red line, which shows the week in which the earthquake happened, is in the most outer side of the graph, which means the distribution was higher than the other times. So that is to say, earthquake caused higher levels of mobility. Similarly, when we look at where that mobility happened in the right figure, we see that the mobility happened in earthquake regions. That's represented by the yellow line. So the other indicators that we have is the displacement indicators, and one of them is the flow indicators. So looking at the displacement flows is a little bit more complex and challenging than just calculating a simple formula at low-level features. Because first of all, we have to detect somebody changing their habitual zone of living. And then we have to be able to say this was due to an earthquake or due to a disaster or a conflict event. So there is a possibility of attribution error, where we attribute the mobility to the disastrous event, whereas this was caused by other reasons. And there is also the difficulty of identifying the address changes in the data due to sparsity of the data, etc. Nevertheless, we have this example to give that we have calculated in our study again, that was in Turkey. Here we look at the CDR-based internal displaced people estimation through origin and destination matrices. So we look at the origin and destination as between earthquake regions versus non-earthquake regions. And the upper side, we see the flows within the earthquake region on the left side, and from earthquake region to other regions in the right side. As you can see, the normal level of flows that's represented by the horizontal red line was surpassed by magnitudes in the week that earthquake happened, which is represented by the vertical red line. So these above normal flows are called the displacement flows. And also by our approach, we are able to differentiate Syrians and Turks thanks to the registration level information that we incorporated in our data preparation with our collaboration with Turkcell. And this information help us to understand the differences between the secondary displacement and first displacement of Turkish people. So another example is from this recent study that assesses the internal displacement patterns in Ukraine as a result of Russian invasion. They use GPS-based approach to estimate IDPs, and they can see they demonstrated the origin destination flows from Kiev to different destinations per week. And as you can see, thanks to their approach, we can see week by week how many people were displaced and to where from Kiev, which would not be possible to know without other types of data. Stock indicators are a little bit different because they show how many internally displaced people or refugees are at a given location in a given time. So again, this is part of our study that happened in Turkey that shows the distribution of internal displaced people as a result of the earthquake. On the upside, we see the secondarily displaced Syrian population distribution, and the lower side, we see the Turkish IDP distribution. And you can see first we were able to calculate the amount of IDPs, and second we were able to see the variation in their distributions. So the important part again here is the data fusion. That's helping us to first validate our findings, and second help us to contextualize what we found. So data fusion on that side is extremely important, but also to develop good models that predict displacement, we need this data fusion as well. So for feature extraction and feature selection. After we are done with mobile data acquisition and feature and indicator calculation and data fusion, now we move on to data analysis. So data analysis includes different methods and applications. For anticipatory approaches, what's most important is the ex-ante analysis to be able to forecast and simulate what could happen as a result of potential disasters. But actually, what we found is that in the literature, the most of studies focus on ex-post analysis, descriptive, especially the descriptive analysis of what happens as a result of different disasters or conflictual events. And there are also studies that use these ex-post data to understand the drivers of these events with ex-post prediction. Maybe I should have given an explanation of what ex-post and ex-ante means first. Ex-post means that we look at the situation after the event happens. So we do our analysis after the event happens. Ex-ante means the event didn't happen and we are kind of speculating how that event might happen. And this has a big consequence on what methods to use actually. Like descriptive and causal analysis kind of focuses on quantifying the causal impact of disaster on a variety of outcomes. And here, in this example, the authors look at the economic impact of the disaster quantified by the number of visits to different businesses. And they were able to tell the amount of impact was caused by the diminished number of visits. So this was done thanks to existence of location data. and this way, they were able to inform policymakers on what kind of effect they might be seeing as a result of the disaster. But of course, this is done after the earthquake, after the disaster they were interested in analyzing happened, which was the hurricane in Puerto Rico. And it is not a way of anticipating displacements. It's more analyzing its effects. Post-disaster predictions look like predicting who is going to be displaced with data in a data where we already observe people who are displaced. So this way we are able to see the features that differentiates displaced people from non-displaced people. And this can include in-group social ties, livelihood destruction at home location, wealth level of individuals, or pre-disaster mobility. We look at this as an example here I'm sharing in the context of Turkey and Syria. As you can see, the collapse and damages buildings as well as pre-disaster mobility were predictors of displacement both for Syrians and Turkish people. This way we can understand who is going to be displaced based on these predictions, but there is no way to know this before the earthquake happens. So to do so, we need forecasting approaches, and these approaches include machine learning approaches or traditional migration models. But the problem with machine learning approaches is that usually you need very long amount of time to be able to infer patterns from displacements that are and events that happen and the relationship between the two. And this is extremely difficult with mobile phone data, which tend to not to exist for such long periods of time. So that's why there are not many approaches that try to forecast ex ante how people would be displaced only with machine learning approaches. There are some trials to use traditional models of migration, such as gravity model or radiation model, or extended versions of it. And here an example where the authors look at drought-induced migration prediction using CDR, using these different models, and they developed their own model, which incorporated the weather conditions as a predictor of people's migration patterns. Another approach is the simulation approach. And there are some studies that use mobile phone data to understand the evacuation patterns of people and to be able to simulate this in case of disaster. There are also some studies like the one that I'm sharing here that try to kind of simulate the refugee destination choices with various data sources. But there are not so many studies that combine the two to understand how the displacement might occur with agent-based modeling, etc. So there is a great potential to explore in this context. So the opportunities in this in anticipating migration and displacement using mobile phone data include increasing data for social good initiatives as well as open source platforms. So both of these opportunities open some space for researchers to better able to use and develop new methods, as well as more options to collaborate. But of course, there are big challenges in face of using mobile phone data for this reason. And the biggest issue is, of course, data access. Data access require good data collaboratives, and they are extremely difficult to form and maintain. And due to that, we see still a lot of blockage in terms of amount of studies that deal with this with mobile phone data in this context. Another issue is data governance. So data governance is also extremely important. In EU, it's done basically by GDPR rules, but also there are other guidelines such as OCHA, Center for Humanitarian Data Responsibility Guidelines to take care of such sensitive data in the context of displacements. So these rules and regulations are very important for and for bringing methodologies in anticipatory displacement, anticipating displacement, because we deal with very sensitive and potentially hazardous data that can be also manipulated and used for wrong reasons. So moving forward, bringing myself to our conclusions, anticipatory there is a lot of room for improving the use of mobile data for anticipatory policymaking in the context of displacements. The biggest opportunity lies in data sources. There is a lot of data source that we still didn't exhaust and understand how to use. For example, roaming data is extremely promising to understand cross-border mobility and cross-border refugee movements potentially. Also, data collaboratives are very promising and very crucial. If you set the goals and the standards of collaboration right from the beginning with incentives, you are going to have successful and sustainable data sharing models where the biggest challenges of data access and data governance are resolved. So this is also very important. And we also want to emphasize that there is a lot of room to improve in terms of methodologies as well. For instance, simulation approaches have been not fully exhausted to better understand how we can integrate mobile phone data sources into existing simulation models for simulating refugee dispersal and their destination choices. Thank you very much for listening. And if you have any questions, you can contact me through my mail address.